welcome everyone. Can you hear myself and Harrison before we kind of kick off?
I can hear you.
Yeah, I know you can hear me. I just want to make sure they can hear me. Okay, here we go, Marcus. Good. Yeah, this is going to be recorded. So yeah, if you have to hop off, you can carry on. So we're going to kick off. Harrison, you can go ahead and introduce yourself. I think they already know who you are. And yeah, we'll take it from there.
Hey everyone, great to meet you. My name is Harrison, the co-creator, co-founder, CEO of LangChain, which started off as an open source Python package, and now is a framework to develop applications with language models. Been working on this for the past few months. Before that, my background's in ML ops and machine learning. Really excited to be here today. Mayo's been an amazing part of the community, and so excited to you guys have learned from the best here. So excited to chat with him and excited to chat with you all.
Appreciate that. So yeah, I mean, we at this point we've gone through the program. Everyone kind of has a decent idea of how things work in terms of embeddings and the model. And LangChain, we had a LangChain fundamentals workshop as well. So I think during the session it would just be an opportunity for the audience to ask questions, and also for you to kind of go a little bit more in depth in terms of areas that people seem to be interested in. So that's dealing with agents. I know that's something that's kind of come up, and then also tabular data or any other area. So this is going to be a bit of a hybrid. Harrison's going to just have some presentations going to go through. But then feel free to ask questions. This is a great opportunity to get him to answer questions. So yeah, I'll let you take it from here, and then we'll jump back and forth between the questions as well.
Yeah. All right. Awesome. I'm going to go straight into some slides, but please interrupt with any questions. Happy to jump around to whatever is most helpful. So I'm going to share my screen. Let's do this one. Can you guys see? Can you guys see this all right? I'm going to assume yes. All right. Okay. So I have two presentations lined up. One is a more high-level overview of LangChain, and specifically, it will kind of like go over. You guys kind of already know what LangChain is, but to kind of like reiterate, open source developer framework for developing LLM applications, Python and TypeScript, focused on kind of like composition and modularity. And there's two really main parts of LangChain. There's like the modular components, and then there's a bunch of use cases. So skimming over the modular components really fast, we have models, we have prompts, we have indices, which are basically ways of doing the embeddings, vector stores that you guys have all been used to. And then there are chains and agents. The chains and agents are most interesting to discuss when talking about use cases. So I'm going to go through, so we're not going to talk too much about those, and we can jump right ahead to what are common use cases. And so that we can see that there are 8 kind of like main ones that people use LangChain for. And so we can go over all of these in some level of varying detail. And then I also heard that there was a bunch of interest in agents. And so I'm happy we can start with that one. And I have a separate slide presentation on basically how to get LLMs to use tools. And so tool usage is one of the main important parts of agents. And so jumping into like agents at a component level, so what is an agent? An agent is defined in LangChain as having 2 kind of like main components. One is the ability to use different tools and interact with the outside world in various ways. And these tools can be things like Google search. They can be things like an arbitrary API. They can be things like a Python REPL, things like that. And so why is this useful? I mean, language models are great, but they don't have access to up-to-date information. They're not that great at doing math sometimes. They can't run code, but they're really good at like reasoning. And so the idea of agents is to use the language model as this reasoning engine, and then connect it to different types of tools that can do various things, and have the language model basically say, hey, I want to use this tool in this particular way. Do that, see the observation of doing that, which could be like, oh, you got an error, or it could be like, oh, the search result returned foo or something like that. You can then feed that back into the language model and ask it to basically incorporate that knowledge into its like planning and decide what to do next. So tool usage is maybe like the defining part of agents. Another defining, although more subtle part, is memory. And so this refers to there's a few different types of memory that this refers to. One, there's like conversational memory. So if I'm talking to an agent and I ask it to do something, and then I ask it to do another thing, and then I ask it to do a thing after that, it should like remember what those tasks that I asked it to do are, and I can build off of them. I can ask it to like refine its answers and stuff like that. Because remember, kind of like as a default, language models are stateless. So unless you give it some type of state through memory, it won't remember that. Another type of memory is memory of the intermediate steps that it does. So an agent doesn't just do like a single call to a tool, it can do like multiple calls to a tool. And so it's often, it's actually, you kind of very much need to remember what those intermediate steps are, so that it can use the results of those intermediate steps when deciding what to do next. And there's a few different ways to do this. If you're just doing like a small number of intermediate steps, you can kind of just keep a buffer of them in memory. But if you're doing a long running program where the agent does 20 steps or something like that, you need to use the same techniques actually that you guys use for memory of retrieval of documents and document question answer. And you can do that with like the agent intermediate steps. So you can pull in semantically relevant pieces of context, which in this cases are semantically similar steps that it did before, and use that to inform its next decision. And then a third type of memory, which is even newer, is basically this idea of like reflection. And so this really contributes to the agent kind of like learning over time. And what this means is that with an agent, you can have the agent or a chatbot or anything really, you can have it kind of like reflect on what it's been doing and what it's observing, and then kind of like update the state of the world accordingly. And the state can be as simple as like, so what's a good example of this? The state can be as simple as like what it knows about the person that it's interacting with. So if I have an agent and it's chatting, and I'm chatting with it, and you know, I keep on asking the agent to do things like look up the weather. It can, and when it says that it's like sunny, I'm like, yay. And then when it's like rainy, I'm like, oh no. You know, the agent can infer over time that I like the sunshine and I don't like the rain. And so that is what we kind of like mean as like the agent's kind of like updating the state, where the state is some internal representation of what it thinks about me and about my preferences and stuff like that. So those make up agents. Agents in LangChain, we have a few different algorithms for getting the language model to use tools, which again are the main parts. We have a few different algorithms for this memory component. And then we also have this concept of agent toolkits. And these are agents armed with specific tools for a specific application. So an example of this might be, you know, if you're working with the Spotify, if you want to create an agent that can interact with like a Spotify API, you want to give it access to the Spotify API spec. You want to give it access to a requests module so it can make requests to the Spotify API. You maybe want to give it access to another agent that can like construct kind of like requests based on the request module and stuff like that. So it's basically you know, we have like 30 or something tools in LangChain. You can give the agent all of them, but if you want to create like a really focused agent, it's better to give it just specific tools that are needed for that specific application. And that's generally what we mean by an agent toolkit. So that's the technical description. And then more on like the use case, as mentioned before, this combines like tool usage, conversational memory, long-term memory, and to create kind of like this, I like to call it like a personal assistant style thing. And so this is a program, an algorithm that kind of like does things on your behalf, learns things about you, takes actions on your behalf, looks up things on your behalf, and again, uses the language model as this like reasoning module. Much like, you know, personal assistants today might kind of like, you know, they're humans, and so they think about what to do, and then they do those tasks, and they kind of execute. And so it is a way of yeah, I think getting these to work well is one, really hard, and I can talk. I have the separate slideshow I have is around all the more technical challenge about getting agents to use tools reliably. But when done right, they can be like really impactful. That's a high level overview of agents. I'm happy to jump into the more detailed slide on how to get them to use tools, but I'm also going to pause a little bit to see if there are any questions.
Yeah, there's some questions in the Q&A side. So one question is about production use cases. So obviously, this is, I mean, for us to talk about conceptually, but I guess people kind of wondering what production use cases are kind of working well with agents at the moment.
Yeah. So I think the ones that I've seen that are probably closest to working are there's some around coding actually, because in coding there's this nice property where you can have an agent write code and then you can execute it and you can get really quick feedback on whether that's correct or not. And then based on that feedback, you can update kind of like the logic accordingly. And so that's a really good kind of like and a lot of these, yeah, and so that's a really good use case. I think I've seen a few kind of like tools that do that. Depends. I don't think they're widely available, so I don't know if that's so. It depends on your definition of production, but there are kind of like products that definitely do that. Web browsing is another one like this. I've seen a few projects that use agentic behavior to do web browsing, right? So you do a Google search, then you might look at all the web pages and you might decide to visit one, and then you want to do like question answering over that web page, or you might want to click on a link or something like that. So web browsing agents are another big one. And then the third one is around kind of like basically like calendar / email management. And I think this is useful because there's a lot of context coming in. And so having a system that can like ingest all that information and then decide how to respond to things or to update the calendar, to delete an event, is very useful for people that have a lot of stuff going on there. So those are like maybe 3 of the more popular production-y ones.
Mm-hmm. And when would you recommend someone uses an agent versus they don't use an agent? Would you say someone who's kind of new to this stuff kind of doesn't really go near agents for a little bit until they kind of understand how things work?
Yeah. So agents are good because they're powerful and allow to recover from mistakes and kind of like allow for more creative use cases. They're bad because you need the underlying model to be really good in order to actually get them to work properly. And even then, there's a lot of guidance that they still need. So I would if you're so I would basically say one, if you want to like play around with things and be amazed, agents are more wowing than chains. If you have a specific use case that you want to get production ready, I would probably start with a chain and see how far you can push it there. And that'll also help you get some familiarity with just how language models work in systems or in general, like prompting in general. And then once you start running into barriers like how do I recover from errors? How do I capture all these edge cases? Those are great. Those are actually edge cases is fine as a chain as well. But basically things like if you find yourself writing a chain that starts to get really complicated with like branching logic, then I would switch to an agent. But if you find yourself writing a chain and it's just a few simple steps, stick with that. That's much more simpler. It's much easier to debug. It's much easier to understand what's going on.
Mm-hmm. I don't know if you can see the other questions in the Q&A tab as well.
I see one about how does the agent know which tool to pick. So maybe this is a good transition to my other slideshow, which talks very much about tool usage.
Cool.
So I'll do that. The background for these slides are much more. I'm also gonna here. I'll go full screen for this. So yeah, this was around putting language models in production. And it's specifically around how to enable language models to use tools. Yeah, basically the agenda of this is, why is tool use important? We already talked about that, so I'll cover that only briefly. Different types of tools, also already talked about that. How to get LLMs to use tools. I'll speak mostly about that. And then the fourth part is just like a spotlight on open API tools. Open API tools are really interesting because the ChatGPT plugins that came out, when did they come out? Like a few weeks ago at this point. Those all use open API under the hood. So getting agents to be able to use those is really, really interesting. So yeah, why is tool use important? It can retrieve relevant context. It can allow the language model to interact with the outside world. We already covered this a bit. Different types of tools, search engine, calculators, retrieval systems, Python REPLs, arbitrary functions can be tools, and then APIs, and that's bolded because we'll talk more about that. Okay, so how do you get LLMs to use tools? And this really gets at the question that was asked as well, which is how does the agent know which tool to pick? Can you specify a different tool than the default one that it picks, et cetera? You tell them to. So the agent is a language model. It takes in a prompt. It follows the instructions in the prompt. And so the prompt should instruct it when to use tools, how to use tools, what they should return. And so that's obviously very high level. So diving into a bit more, and that sounds really simple, but a lot of challenges emerge. And so I imagine, and so these are also again related to the question, like getting language models to use tools in the right scenario, getting them to not always use tools or not using tools incorrectly. And then parsing the LLM output to a tool invocation. This is, if you've used the LangChain toolkit, you often run into could not parse LLM output errors. And so I want to talk a little bit about that. For getting language models to use tools, there's a few ways to do this. Again, one, you tell them to. So all of these are, or the first two are very related to that. So you have instructions or a system message for the agent. You should tell it explicitly when to use tools, when not to use tools. The description of the tool, so all tools in LangChain have a tool description. This is used to tell the language model when to use tools. So if it's not using a search tool to look up current events or something, you should change the description of the search tool to say, hey, use this to look up current events and stuff like that. 3 is another prompting strategy. So I've noticed that when you have the instructions at the beginning, by the time the language model gets to the end, sometimes it forgets some of the instructions, especially if it's in an older version of a language model. And so if you repeat the instructions at the end, not fully, but just remember to use tools when you need to or something like that, that kind of jogs its memory. And so I found that helpful. And then another thing is if you have a bunch of tools, say you have 100 tools, you can't really fit the descriptions of all of those into the prompt. But what we can do is we can actually do a retrieval step first. So just like in document question answering, you retrieve the 4 most relevant documents. Here you can retrieve the 4 most relevant tools and then pass those into the prompt. For getting language models to not always use tools, because sometimes you just want to have a conversation with them and they don't need to use tools. There are some more kind of tips and tricks here. Again, the system message and the instructions, repeating the instructions at the end, those help a lot. And then a third thing that we've found is if the language model will often want to use tools even when it should ask for clarification or something like that. And so if we explicitly have a tool that's human clarification / input, which really just responds to the user, but the language model treats it as a tool, that we found that to be a nice hacky trick for getting it to basically be better at asking for clarification, having conversations, stuff like that. And then this is a bit more in the weeds, but basically how do language models actually use tools? They output text. That text can then be parsed into the tool to use and the input to the tool. But often, language models don't always output text in the right format. And so what do you do then? Or how do you get language models to output text in the right format? 1, you can ask them to output more structured responses. So things like JSON. 2, we have this concept of output parsers in LangChain, which help exactly with this issue. And then 3, like if you get a bad output, you can actually ask a separate LLM to kind of like fix that output. And I'll skim through this a little bit because I don't think it's super interesting here. But basically, the idea of output parsers is you can define in code with a pydantic model what the schema should be. And so this is for a generic thing, but like generically, you could have this be like the tool to use and then like the tool input or something like that. You can then use that parser to get the formatting instructions because you need to tell the language model to output things. And so this goes from a pydantic model to a string that can be put into the prompt to format things accordingly. And then after you pass the prompt to the model, you can then parse the output and you can get back the now parsed pydantic model. And then basically the idea, I'll skim over this a little bit as well, but there's some output parsers in LangChain that wrap other parsers. And you also provide a language model. And then if you get an error in the previous parser, you can fix it by basically asking it to fix it. And this is another example of that. And then, yeah, quick spotlight on OpenAPI tools, because these are really relevant for ChatGPT plugins. We found that like TypeScript and JSON to communicate the parameters was really, really important here. And then we also found that if we composed different like chains and agents together, that helped. So specifically what this meant is rather than giving the agent access to like 5 different OpenAPI specs, would wrap each endpoint in its own chain and then give the agent access to those 5 different chains. And that helps because now you have a dedicated chain that's dedicated for knowing how to interact with one single OpenAPI spec. And that's way easier than having one LLM that has to know how to work with like 5 different OpenAPI specs. So that's that for the presentation on kind of like tool usage.
Nice. And would you say the main point here is that the LLM can kind of decide what tool to use, whether to use an API or to use a SQL chain or to use even just a vector store retrieval? The point is that it has this kind of agency to decide the appropriate steps to take.
Yeah, exactly. That's exactly right.
Cool. Yeah. So there's more questions.
Yeah. Okay. So the first one we already answered. The second one, yeah, that's exactly right. Chains are more predictable. Agents are harder to control. There's a question about contributing to the code. Maybe I'll answer that at the end. So production use cases for agents, also already answered. Is it possible to use on-prem version of ChatGPT, like Alpaca with LangChain framework? Yes. So we provide like a bunch of different wrappers. I think we actually have one for GPT for all, which is based on Llama. And I think we have some bindings for the Llama CPP models. And so, yes, absolutely. One interesting thing that I've noticed here is that sometimes the prompts that you want to use, they're actually different for the different types of models that you might want to use. So like if you're using Llama or Alpaca, you might need to play around with the prompts and do some prompt engineering. And we have a framework in LangChain to kind of like help with getting stuff work better off the shelf, which we call like prompt selectors. And these are basically, rather than hard code like a default prompt for a chain, we have a prompt selector which takes in a language model and then chooses a prompt based on the type of the language model. And so this isn't super built out yet because everyone still uses OpenAI, to be honest. But the idea is that once there are viable alternatives, we'll start building out these prompt selectors more. Can you talk more about the last part where you mentioned to wrap the API call in one chain? Yeah, absolutely. And so this gets, let me actually jump to another use case, which is interacting with APIs, because I think this kind of gets at it. So And this also gets to the question above, which is a really good one around like, chains or agents. It seems like chains are more predictable and agents are sometimes harder to control. Like that's exactly right. And so for a lot of the use cases, and I can go through some more as well. I heard that like querying tabular data like CSVs was really interesting. But for a lot of the use cases, there's generally two ways to do things. One with chains and one with agents. And as you described, chains are more predictable and agents are harder to control. Agents are more powerful though because they can recover from mistakes. They can just use multiple things in different manners. So what we've found to be helpful is if you have like a complicated API spec, um, what you want is you really there's almost like two things that you want. You want one, like the ability to think about when to use that API endpoint. And then two, after you decide that you want to use that API endpoint, you want to actually be able to translate natural language into some queries for that API endpoint. And so what we've done is we've basically treated, or what you can do is you can treat those as like two separate things. So you can wrap a single API endpoint in a chain. And this has the benefits of making it more predictable, making it more focused, and really kind of like getting as much performance out of natural language to this API as possible. But it has the downside of it only works with like a single API spec or something like that. So then what you can do is you can give that chain to an agent, and that agent can then decide like, okay, should I use this chain or should I not use this chain? And so the agent is thinking about like when to use the API endpoint, but then the chain is thinking about how to use the API endpoint and like how to go from natural language to some API inputs, basically. Yeah, so that's kind of like what I meant by having the agent use chains. That is a good question.
So, because from the outside looking in, it sounds like magic, right? How is this thing able to decide, what to do, when to do it? What would you say are the key prompts that kind of make it decide what direction to take for each tool? I mean, more of I know what's going on under the hood, but I guess for people it kind of sounds like magic. How is it going to know what to do? What would you say those are?
Yeah, I think there's like two components. One is kind of like the description of the tools, and so this helps. Like, if I gave Mayo like 5 different tools, he wouldn't know what they did unless I told him what they did. So similar to that, you have to tell a language model what each tool does, and then it will kind of like learn that. But then even after, you tell you even if you were to give someone a description of every tool, they still have to be like smart enough to use the tools, or like figure out how, like when to use the tools and reason about that. And so there's also prompting strategies that basically try to get the agent to think more critically, basically induce better reasoning logic from the agents. And so if you guys have heard of like chain of thoughts or chain of thought prompting or stuff like that, it's very similar to that. So chain of thought prompting is basically the idea that if you just ask a language model a question, it will do fine. It will answer it sometimes. Sometimes it won't know how to answer it. But you can get much better results by basically tricking it into like thinking like step by step, basically. Because the idea is that when it starts off an answer, let's think step by step. In the training data, it's basically seeing more intelligent answers. It tries to think about it step by step. It's almost like if you want to like really anthropomorphize it, it's kind of like type 2 thinking versus type 1 thinking. Like rather than just trying to give an answer right away, it like thinks a little bit more critically about what to do. And so there's some similar techniques used to get the agents to think critically about what tools to take. And specifically, this uses a framework called like React prompting, which stands for like reasoning and acting. It was a great paper. It came out about like 6 months ago, and it's really focused on how to get it. I don't think they called them agents at the time, but how to get agents to think more critically about what to do and then take actions. So yeah, there's kind of like 2 main components, this like prompting strategy to get it to think better. And then even if it can think well, you still have to tell it what the tools are good for. So it's a combination of those 2 things.
see. All right, there's more questions as well. I think Victoria's asked another question. Do you have examples with chains and agents in the chat OpenAI mode? Most of the examples are, I just lost that. Yeah, most of the examples I can find is zero shot OpenAI mode.
Yeah, I think there should be some examples. I think the main difficulty that happens with the chat models is that they're just not as good at following instructions on the outputs. So you run into more output parsing errors, but they should work the same out of the box. Off top of head, we can check out the documentation. So yeah, we have some. So here's an example of a custom language model agent with a chat model. And so this uses like chat OpenAI. You're definitely right that, and so then also, yeah, so as I said, like the default prompts, so like the zero shot, so like this is like the most common one. It uses like a zero shot React description. As you pointed out, those don't work amazing for chat models. But we have like a variant of this, which just uses a different prompt under the hood. And it's called chat zero shot React description. And these are designed to work well with chat models. So you can see here that we initialize it with a chat model.
Yeah, some more questions. JavaScript, Python parity.
Yeah, that's a great question. So I would say they're aimed at like slightly different things. Python definitely has more of it's quicker to incorporate some of the more researchy ideas because that's often because a lot of academic papers are written in Python. It's also, yeah, it is better at data stuff, and that's because there is better general data engineering support in Python. And so for things like retrieval, embeddings, document loaders, tokenizers, there's just better support at the moment in Python. So it is a bit more heavy on that. Retrievers are an interesting one. We actually had some implementations in the JavaScript package that were more advanced than some of the stuff in the Python ones. So I wouldn't say that is a big differentiator on the retrieval side, but for document ingestion, which does play very hand in hand with retriever, but document ingestion, some of the more researchy concepts, the Python one is generally ahead. The JavaScript package is generally more ahead on like having async support, having support for some like more kind of like, more web app stuff. So more examples on how to use it with like WebSockets, more async support, stuff like that. So the core types of chains and agents should be pretty stable at the moment. Python higher on data support, JavaScript higher on kind of like more like web appy support. Aside from the compute usage, what are the trade-offs on updating an existing LLM model with custom data versus providing context with embeddings? So I'm assuming that means like fine-tuning versus providing context with embeddings. The trade-offs are, in my mind, it's much easier to get started if you just provide context as embeddings. You don't have to worry about fine-tuning. Fine-tuning is like harder than providing embeddings generally. There's a lot more things that can go wrong. It can there's a lot more things that can go wrong. So it's generally easier to get started. It's also easier to keep it up to date. So if you have data that is changing at some periodicity, you can either fine tune the model or update the embeddings. And so, fine tuning can be more costly. It can be, it's also more finicky, like it just goes wrong sometimes. And so like just updating the embeddings can often be simpler. And it takes more time. Like it's much faster to update embeddings than to fine tune a model. I think fine-tuning a model is better if you want to do like more well, one, like, yes, like the okay, so fine-tuning the model is better because you just have to do a single call to a language model, and you don't have to provide the context. So you'll be providing less tokens, the latency will be lower, and stuff like that. The another benefit is I think it's probably more helpful for like if you want to like really learn the style of someone. So if it's just about retrieving factual information, I think if you fine tuned versus did some like retrieval with embeddings, I think it would be like probably pretty similar. But if you want to basically be able to do output in the style of a custom person, that's like something more where you have to like really observe like all the data at the same time and kind of like extract the style. And so I think you'd be better off fine tuning for that use case. My recommendation would be if you're doing like question answering, start with embeddings and stick with that until yeah, I mean, again, like if you're doing question answering, you generally probably have data that's changing pretty rapidly, or at least at some frequency. So honestly, I just always do embeddings. I'd always do retrieval augmented generation.
How would you recommend automatic updating of the embeddings? Because obviously you can run the ingestion process one time, or you can do it manually or through the API. But how would you structure the architecture to make it so that it's kind of all an autopilot? So if documents change or you add more documents to some sort of corpus of data, the embeddings change as well.
Yeah. Here's the first easy answer, which is just you update everything. Like you delete the whole thing and you just repopulate it. And that sounds like it could be really wasteful, but like generally the process is pretty fast and embeddings are kind of cheap. And so I guess that depends on the corpus. Like if the corpus is big enough, you're not going to want to do that. But if the corpus is small enough, for example, there are a few different people that do question answering over the LangChain documentation. And I asked them what they do about this, and they just refresh everything. They delete everything and then they re-index everything because the LangChain documentation isn't huge. It only takes a few minutes. It doesn't cost that much. If your corpus is large and you don't want to do that, you basically need to keep some mapping of document to chunk. And then if a document changes, if a document's deleted, you delete all chunks that are associated with that document. If a document is added, you add chunks for that document. If a document is changed, I think the best way to do that is just update all chunks associated with that document, because a step in the process is take the document and split it into chunks. And so even if like only one sentence changed, that could affect the chunking of the document pretty substantially. You could add in logic to kind of like see if each chunk changed, but my guess is it's like not really worth the effort to write that. Like you'd maybe be saving a few different chunks and you'd have to write this semi-complicated logic that you need to like maintain and make sure isn't bug free. So that's how I would kind of think about it.
Yeah, more questions coming in. Okay, use case of doing analysis across tabular data and the structured data. So for example, the customer did this thing X times to the app. They contacted customer support and had a negative interaction. Would chains or agents work well for this?
Sorry, I'm trying to find that tabular structured data. Okay, yeah. So I think there's three different ways that we see people doing question answering or just like interacting with tabular data. One is you kind of load it the same as you do any unstructured data. You load the CSV, you do some pre-processing so that you add in kind of like you now have like these records, which are like the header mapping to each value. And these are all in LangChain, by the way. So for example, if we go to like indices, document loaders, CSV loader, there's a loader that loads in kind of like context for this. So one, you can just load it as a normal document and then do the same retrieval augmented generation steps. When is that good? That's good when there's a lot of text data in the CSV. That's good when the data isn't super, super large. Or maybe a better question is like, when is that bad? That's bad when the data is large and constantly changing, because you don't want to be doing that indexing step every time. And if it's large and constantly changing, then you're going to have to be doing that indexing step a lot, and that indexing step will be expensive. If you have to do the indexing step a lot, but it's inexpensive, that's probably fine. And if it's large, but you have to do it only a few times, that's maybe also fine. But okay, so now let's assume you're working with like large amounts of data that's updating quickly. Again, there's chains and agents. So for the chains, there's a sequence of steps that you do, which is generally convert natural language to a SQL query, run the SQL query, get back the results, see what happens. If you now start wanting to add in like error handling, like what happens if the SQL query is wrong, stuff like that, that's when I'd recommend switching to use an agent, because it can recover from those errors pretty quickly, and it can string multiple of those queries together. It's just generally like more flexible.
Let's see. Okay, if I have access to an API like Salesforce, how can I create a tool, the agent toolkit, to access? Is there a code sample to get started on this?
Yeah, so we have some documentation on custom tools, basically. So there's so it's actually, so the simplest way is probably using a tool decorator. So here you just have like a Python function. If you just add this tool decorator, boom, you can now use it as a tool. So we add this tool decorator here, we add this tool decorator, that looks like duplicate. Oh no, we're actually adding information we're adding some information here. Anyways, you add the tool decorator there, and then you can pass that tool to an agent and kind of use it as is. So this is like the easiest way to get started with custom tools. If you want more complex things, you can also subclass the base tool. This is useful for when you want to add like a longer description or stuff like that. But yeah, there's this custom tools notebook that should walk through all of that.
Okay. Some ideas to test LangChain code before deploying to production.
Some ideas to test LangChain code before deployed in production. Yeah, I mean, I think this really boils down to how would you test like an application built on an LLM before deploying to production? One, I think actually this is so yeah, we're thinking a lot about this. We're thinking a lot about how to go from prototyping to production. I think the best thing that I would recommend is you come up with a list of like examples, and these can be like positive examples, negative examples, examples where the application, the chain, the agent, whatever, should make a mistake, should not make a mistake, where you have ground truth. You come up with a list of these examples, and then you basically run the chain or agent over those examples and see what happens. I wish there was a super like quantitative way to like say like, like why is this hard? It's hard because like the output of these chains and agents, it's not like a single number that you can check if it's right or not. It's oftentimes like a natural language response. And so we actually did a webinar on this yesterday around evaluation. And so there's some interesting ideas here where you can use a language model, a different language model, to evaluate your application. But that's the most advanced one, and it's still kind of like exploratory. So I would recommend get a bunch of examples, run the chain or agent over them, look at the outputs by hand and just observe what the outputs are. And that'll also give you some like intuition for like what is actually going on. And so I think I would always recommend doing that. Like that's the most important one. You can then start to automate that by maybe using like a language model to look at some of the responses and flagging things that seem incorrect. So that's how I'd approach it.
Yeah. Can you give a strategy around using baby AGI or auto GPT? Then would that be an example for React prompting?
Yeah. So baby AGI, so that's a great question. We actually added recently a section on autonomous agents. And actually, if people are interested, I wrote a blog on this yesterday as well, because I think this is really interesting. And I think it's different than React prompting. And I think there's some, and so this blog kind of like goes over like what React prompting is, and then compares it to Auto GPT and Baby AGI, and actually some other things. But Auto GPT, it doesn't use React prompting. Instead, but it still asks the agent to do a similar thing where you think, then you come up with an action, then you like reflect on your action and stuff like that. So it's a different style of prompting, but it's a similar idea. Both and then Baby AGI does something different where it actually plans out steps ahead of time and then it like executes on steps. And so like React prompting and Auto GPT go like a single step at a time. It's like it like thinks like, what step should I do? Then I do that step. Baby AGI is really interesting because it actually thinks out like multiple steps. Like I need to do these 4 things. It then goes and does the first one, and then it looks at the response. It looks at the remaining 3, and it updates a task list. And so it comes up with maybe like 3 new tasks or something like that. And so it's different prompting strategies basically. And both Auto GPT and Baby AGI are designed to do more long running tasks. Like I think the example initially for Auto GPT was like, like increase my net worth or something, right? That, right? Where some of the React chains are more designed to like answer immediate questions, like what's the weather in San Francisco today? And so I think that there's some slight like architectural differences as well. But basically, yeah, the main differences I would say are different prompting strategies. Baby AGI has this really interesting plan and then execute framework, and the different like objectives that they're trying to solve.
How would you suggest that people measure and kind of manage the cost of doing all of this, right? Because obviously there's a callback manager. I know there's a callback manager at LangChain, but generally, how do they, what ballpark are they looking at in terms of running these agents with the tools? I know there's a lot of prompts to the model under the hood. Is it like approximately $1 per query, or what are you looking at in terms of cost of this?
Yeah. So Baby AGI and Auto GPT, because they have longer prompts and more detailed ones, they rack up costs pretty quickly. And so I think I don't have exact numbers on me, and it probably depends on what model you're using as well. Like if you're using GPT-4, you can definitely start to rack up costs pretty quickly. And for some of the chains and agents, even though they're smaller than Baby AGI and Auto GPT in terms of the calls, you can still rack up a good amount of stuff as well. For monitoring costs, there is a callback manager where we're working on, to be honest, I wouldn't say there's an amazing solution at the moment. We're working on making it better. You can also do it through the OpenAI kind of like page. I think they show costs per query, so you can kind of like get a sense there. But yeah, we have a callback handler in the documentation. So if you go here, and then I think there's some, so like how to track token usage. You can basically get the total costs of anything that's in there. Same down here as well. So here we can see that an agent executor chain. And again, this is using like an older model, so it's using text DaVinci 2, but you can see that I think it's using text DaVinci 2. Oh no, it's just using text DaVinci 3. So this costs like 3 cents. So it's not that much. But if you start to use like GPT-4 on longer running things, that can start to get pretty expensive.
Do you have any recommendations for optimizing, just managing costs better, optimizing costs? Yeah.
I think where it really starts to get bad is when you're running agents in a really long loop. But honestly, I've mostly seen people doing that for more out of fun than like production settings. I think for production settings, that's like not good anyways. So I guess my advice would be like, don't do that. And then if there are more things that you want to optimize cache for, like in question answering, you can. So this is actually one thing here, and we're gonna release a blog post and some stuff around this tomorrow. Actually, is I think like a lot of the costs come when you have big documents that you want to put into context. And so you can do some clever stuff around contextual compression. So you can retrieve documents, you can then compress the documents using embeddings or other things like that. And then pass a filtered set of like sentences into the question answering thing. And so yeah, there's also other things you can. So there's other types of contextual compression that actually increase costs, but also increase accuracy. And so, yeah, we'll have more on this tomorrow, but I would keep an eye out for that.
Then what would you say about edge cases or just cases that like say multilingual? Because there's some people in the audience who are not English or they're trying to use LangChain for non-English applications. So how does this whole approach with embeddings or agents change with the multilingual application?
Yeah, this is a really good question. I haven't explored it personally myself to have a strong answer on this. I know there are some embeddings that are specifically tuned for multilingual kind of stuff. So I think Cohere actually has really good multilingual embedding support. Hugging Face also has a bunch of models. They're probably not good enough to use as agents, but you can probably use embedding models that are specific to languages on Hugging Face. And then I think GPT-4 is pretty good at most languages. But I haven't played around with it a ton myself to have a great answer here.
Okay. So generally for people who have these massive CSV files, basically, what's your recommendation? Because obviously you can split into chunks and try and use the CSV loader, but the problem is like if you ask a question that requires to sum all the rows, the chunks, there's no way the chunks are gonna catch that.
Yeah.
So how would you typically recommend people with CSV files? I know obviously you've got pandas on
Yeah.
Python, but just generally, what's the recommended solution with that?
Probably, yeah, load it into SQL or load it into pandas, and then use a SQL agent or a pandas agent to interact with it. And so the pandas agent will write some code that can use the pandas data frame. The SQL agent will write a SQL query, and so it should be able to do some like some as in SUM operations and stuff like that pretty well.
Yeah. And then, yeah, there's some other questions about the future of LangChain. There's quite, obviously when OpenAI came out with the plugins, there's questions of, are we still going to need LangChain? Is this course still going to be relevant? Because it's centered around LangChain. So I guess, you can kind of put the people at ease and kind of, I guess, share your thoughts on that. And that there's no reason to worry about implementing LangChain just because OpenAI's got these plugins and retrievals coming up.
Yeah, I think LangChain it's different target audiences. I think LangChain will be a more flexible framework for developers trying to build these things. I think I think there's also really real cases to not want to use like chat. If you think about it, chat GPT and the plugins, it's not so much a model as it is like an application. And so if you only want to use that as your application, then that's probably all that you need. But I think, I'm a believer that there's more applications that people want to use one than chat. And then even if there is chat, there's different interfaces. There's different kind of like ways of using it besides kind of like the OpenAI style. And so, yeah, I think LangChain will be very helpful for that.
Okay. So you'd say use LangChain when, how do you, when you use LangChain, when you use a plugin, when you use Llama Index, which someone else just brought up. So I think it's, for someone who's outside this whole space, it's kind of confusing to decide when to use what.
Yeah, my view on plugins is that they're not readily available yet. It's unclear like what exactly they are. I would probably not get started using them, to be honest. I don't think they're in a mature enough state where I would recommend that. Llama Index has some interesting kind of like indexing techniques for like using trees and stuff. But I think what we've seen is that vector stores are kind of like the dominant one, and performing the best. And I think we actually probably have better support for vector stores in general. And so I would probably recommend getting started with the vector store retrieval QA chain. And then plugins, I think it's like a little bit of like wait and see kind of thing. And so I think it's still really early there. And then for Llama Index, I think if you need more complex indexing structures, you can take a look at them for that.
Yeah. There's a question here about visualizations with agents. Is that possible to have data visualizations?
What do you mean by that exactly? Like of what's going on in the traces? We have some printing to standard out, and we'll add more tracing support in the next few months.
Okay. And then Marcus asks about LangChain. Does LangChain have an OpenAI plugin?
No, I mean we have examples for how you can turn your applications into OpenAI plugins, but we ourselves don't have one.
Okay. Crystal Bell's asking again, how can I contribute to LangChain?
Open a PR. Open a PR. I think there's. I mean, yeah.
Cool. Yeah, before we kind of wrap up, do you want to share, what the future holds for LangChain? We just got started with the year. We're still in the first quarter of the year, so there's still a long way to go, and there's a lot that can happen this year. So, yeah, what can we expect? What's the future for the rest of this year, and just generally beyond this year? Because you just raised a couple $1 million, so congrats on that. And yeah, so people are kind of excited to know what's next.
Yeah, the overall goal is to make it as easy as possible to develop language model applications. We're going to be focused on developers and developer tooling. So we're going to continue building out the open source Python packages, because I think those are the things that contribute most. We'll also probably build some tooling on the side. So like a lot of the stuff around evaluation, a lot of the stuff around tracking token usage, a lot of the stuff around visualizing agent stuff. We'll build tooling to help developers, like everyone here, build applications with language models in a more seamless and easy way.
And what would your recommendation be for quite a large part of the audience who are not technical by background? All of this is a lot to take in, especially when you don't even know how to code, or you're a business person, right? So
yeah,
how would you recommend the steps they take? Because I know we spoke briefly about fellows, the LangChain fellows, or some sort of way to aggregate that. How would you suggest that we deal with people who your calendar is showing, Harrison?
Yeah, sorry, I have a meeting next, so I'm just trying to let them know that I'll be a few minutes late.
Yeah. So yeah, just before we wrap up, yeah, just advice for non technical people in the audience, or people who are interested in using LangChain but they don't know where to begin. Obviously, there's no LangChain devs website yet. Maybe I should build that. Who knows? But yeah, where do they go? What are the next steps for them?
Yeah, we have a Discord server where there's a lot of people that are answering questions, and so I think there's a lot of really knowledgeable people in there, and so I would bring some questions there. We're also constantly kind of like working on making our documentation more kind of like user friendly, and there are a lot of great people like like yourself and others who are making YouTube videos and trying to make this as accessible to folks as possible. I think, yeah, we really are focused on building developer tooling, but we want that to be developer tooling that's easy to use for as many people as possible. And so, we're probably not going to build a UI component, but there's also, we'll try to make it as easy to use. So another option is, start coding yourself and pick that up and dive into that. And hopefully we can have some, your tutorials are already awesome for making it really, really easy for people to get started. And so hopefully we can have more content like that.
Awesome. Well, thanks a lot for coming on and helping to wrap up the program. It's been 2 weeks of people putting stuff together, and yeah, hopefully see you next week in person. So that's going to be fun too.
Awesome. All right.
All right. Yeah. Bye-bye.
Great to meet you guys. See ya. Thanks for having me.